Hi everyone, in this video we're going to talk about univariate statistics. So PROC means with a no print option is the same as using PROC summary. So let's write a PROC means statement. You can see I'm specifying the data and the run. I've specified the title. You can either do it between the PROC and the run or before you run the PROC. It works the same way. And here you can see that it took every numeric variable and gave me the number of non-missing observations, the mean, the standard deviation, the minimum, and the maximum. So I don't have any subject numbers missing, that's why that's 1,000, but there's some white blood cell counts missing, that's why it's only 908, and some red blood cell counts missing, that's 916, and you can see cholesterol has the most missing values with only 795 not missing. By default, PROC means is going to give you statistics on every single numeric variable in your input SAS dataset. If this dataset contains a lot of numeric variables, you might end up with a huge table. You can specify which variables that you want the numeric statistics on, and that's with a var statement. I'll show you in a minute. The default output includes the number of non-missing values, the average, the standard deviation, the minimum, and the maximum. You can control which variables to include in the report using the var statement that I'll show you in a minute. The statistics that you want in your output are chosen by selecting options in the PROC means statement. This is some sample output of descriptive statistics with the keyword and the description. Let's look at some code. Maximum decimal is a keyword that controls the number of places to the right of the decimal point that you want in the printed output. Typically it's 2 or 3. You can see in this code here I have chosen maximum decimal equals 1. Max dec is blue and 1, which is the chosen value, is in green. So here we're computing the number of missing and non-missing. That's why you see the n miss after the dataset specification. The mean, the median, the minimum, and the maximum for the red blood cells and the white blood cells. So the var statement specifies red blood cells and white blood cells. Those are the only two numeric variables that I want summary statistics for. And in the PROC statement, you can see I've specified which statistics I want in the output with the number of decimal places. If you want to see statistics for each level of another variable, you can include a by statement, listing one or more by variables. Remember that you have to sort the data set by those same variables in the by statement before running the PROC means. So here you can see I have all the data together, and here you can see that I want them separated by gender. So I'm first sorting by gender, and then I'm running a PROC means on red blood cells and white blood cells by gender. And here you can see the output. I have a separate output for females and males. The class statement is similar to a by statement, but it's different when you look at the output in that you'll end up with only one table. You also don't have to sort before using a class statement, but you do have to sort before using a by statement. Here you can see that gender became the first column, and for each gender it's breaking it down into the two numeric variables that I specified in my var statement. SAS uses formatted values of your class variables. Using a format statement in the procedure and changing how the class variable groups your data can be done without modifying the original dataset. Suppose you want to see some basic summary statistics broken down by subjects with cholesterol levels below 200 and above 200. Here you can see I've created a PROC format for the cholesterol, and when I run my PROC means, I specify that I want cholesterol formatted with the format I created above. Cholesterol is my class variable. Because I'm using class instead of by, I don't need to sort by cholesterol before running the procedure. And now you can see instead of separating by gender, we're separating by cholesterol levels. So for low and high, we have the summary statistics for red blood cells and white blood cells. If you have a very large data set that isn't sorted, the class statement is more efficient. If the data set is already sorted, then the by statement will run faster than a PROC means with a class statement. Here you can see I can create this output with either PROC summary or PROC means, but what I'm doing here with the output statement in my PROC means is I'm outputting the summary statistics into my summary. And I'm labeling the mean red blood cell count, mean RBC, and the mean white blood cell count, mean WBC. An output statement tells PROC means that you want to create a summary SAS dataset. The keyword out is used to name the new dataset. Next, you can specify exactly what statistics you want in this dataset, and after the equal sign, you can provide a list of the variable names that correspond to these values, like I did with mean RBC and mean WBC in the previous slide. The order of the variables here corresponds to the order of the variables in the variable list. The no print option suppresses printed output. If you use PROC summary instead of PROC means, then you don't need the no print option. It's the default for this procedure. If you omit the variable list after the mean equals keyword, then SAS will give these summary variables the same names as the variables listed in the var statement. I strongly recommend that you don't do this, as having summary stats with the same name as the raw data can be very confusing. In this example, we will output the mean, the number of non-missing observations, and the number of missing observations, as well as the median. You can see here I've named them so that I can distinguish which are the summary statistics for red blood cells versus white blood cells. The output option AutoName causes PROC means to create variable names for the selected statistics by using the variable names in the var statement and adding an underscore character followed by the name of the statistic. Here you can see I'm using the AutoName function. Here you can see it picked the variables and put underscore the summary statistic name. Because AutoName is a statement option, it follows a slash in the output statement. It creates consistent and easy to understand variable names. Here it is, backslash AutoName in the output statement after you specify which statistics you want. If you need to output summary statistics for each level of one or more classification variables, you might consider using this code. Notice I sorted the dataset learn.blood and I output it in a temporary dataset called blood. I'm sorting it by gender. Then I'm going to run a PROC means by gender for red blood cells and white blood cells. The output dataset is called by underscore gender, and I'm storing the mean and the number of non-missing values in mean RBC, mean WBC, N underscore RBC, and N underscore WBC respectively. This is what my output looks like. This is the same program, but I'm replacing the by statement with a class statement. And notice I don't need to sort by gender beforehand. This is what the output looks like. You can see here that I have the first row where no gender is specified, and that is the grand mean and grand number of non-missing values for each variables. Then below for type 1, it's breaking it out by gender, female and male. Female is first because F comes before M in the alphabet. The underscore type underscore equals 0 is the mean for both males and females, the grand mean. The underscore type underscore equals 1 is the mean for males and females separately. If you want to omit the observation with the grand mean, you can use the n-way option in the PROC means statement, and that will omit the grand mean where type was 0. Suppose you want to compute the mean and number of non-missing values for red blood cells and white blood cells for each different combination of age group and gender. So gender and age group are my class variables. I'm going to output it into a data called summary, and I'm using the autoname function to let SAS name my variables. Even though there are only 2 levels of gender and 2 levels of age group, there are 9 observations in the output dataset with 4 values of type. Another option to make type easier is to read it using char type. Char type causes the type variable to be character string of 1 and 0s. So you can see here 0, 0 is the grand mean, and then I have them broken down by the second variable 0, 1, which is age group, then by the first variable, which is gender, and then type 1, 1 is each combination of gender and age group. Adding the chart type option to PROC means causes the type variable to be a character string of 0s and 1s. So notice 0, 0 is the grand mean, 0, 1 is the mean for each age group, which is the second variable I specified. 1, 0 is the mean for each level of gender, which is the first variable I specified. And then 1, 1 is the mean for each combination of gender and age group. Underscore type underscore can be used to create separate data sets, one for the grand mean, one for the means broken down by gender, one broken down by age group, and one containing cell means. Since each data set has a different selection of variables in each data set, use the keep or drop data set option to make your selection. Underscore type underscore is a character variable because the char type option, and you can use it to route each observation to the proper output data set. Each statistic keyword is followed in a set of parentheses by a list of variables for which you want to compute this statistic. This is another option you have in PROC means. The program here computes the means for red blood cells, white blood cells, and the number of non-missing values for all 3 variables, RBC, WBC, and cholesterol, and the median of cholesterol. This drop option causes the colon wildcard notation. All variables beginning with an underscore character will be dropped. That's what you see at the end of the line that begins with output, which is the 3rd line of code. In general, name colon is used in any location to refer to all variables. It's the equivalent of an asterisk as a DOS wildcard. The drop option uses this wildcard notation, and all variables beginning with an underscore are dropped. This is a little exercise for you. You can use the SAS dataset college to compute the mean, median, minimum and maximum, and the number of both missing and non-missing values for class rank and GPA. Report these statistics to 2 decimal places. Pause the video here and retrieve that data set so that you can practice using the same code I used in the previous slides.